In this video, we are going to learn some ways that we can control how our output is displayed. Here I've defined 9 variables and given them values, and then here I've printed them out. Notice I just printed them one after another and put end-l so they'll be on 3 different lines. Let's go ahead and run this. Here all the numbers are bunched up, so they're just messy. So the first solution to fixing this would be to add spaces in this. So let me paste some code here that has a space between each one. And now when I run that, they look better because you can see between the numbers. So that's a good thing. But they're still messy. They don't line up. They don't look neat and tidy. So we want to learn a way that we could make these numbers neat and tidy and in order. For these commands, we need to include a header file called iomanip. And the first command that we're going to use is the setWidth command. And notice that it goes right inside a cout statement with that insertion operator. So you do set W and parentheses. This is a function call. This one actually expects one argument. It needs to be a value of an integer. So I'm going to make this a constant int because I don't want it to change. And I'm going to make it 8 big. And then I'm going to use that constant. And here's the argument to my setWidth. All right, so there's my command. It goes inside the cout statement. And I show that, and here's what it does. It creates a field that is 8 big, and then it puts the very next value in that field. So see how that works? It says here, create a field that is 8 big, and then put the value in variable num1 inside that field that's 8 big. Well, they still won't line up all the way. In fact, we want to have a field for each of these variables. So I'm going to replace the spaces with a call to the setW command. It stands for setWidth. And I'm going to put one of these for each of these variables that I'm printing out. And then we'll see what that looks like. So I'm actually creating 9 fields. All of them are exactly the same width. If I wanted to be 2 different widths, I'd create another constant for the other width that I wanted it to be. And there you go. And look how nicely they line up. Now notice one thing. It makes a field as big as you make it, and then it puts a number in there. Notice that it right justifies that number. So it puts it in the right side of the field. This is the default value, and you can change that default value by using the command left. All right, that's another iomanip command. And what that does is that sets the justification to be left. And now look, there's a field of 8, and it put the number into the left of it. There's a field of 8, and it put the number to the left. So now we still have fields that are 8 big, because our setW does that, but we have chosen left justification. Notice here that we only did it once. So justification, you set it, and it stays that way until you change it. So if I wanted to do the top one left justified, I would set that to be left justified until I wanted to change it, and then I can change it back to right. And then I can do the rest. So let's see how that works. So there, my top row is left justified inside those fields that are 8 big. And then I switch it to right, and these are all right justified. All right, so you only need to change the justification when it needs to be changed. You don't do it every time like you do with the setWidth. And FYI, there's no center justification, so you get to either choose right or left. All right, let's go ahead. I'm going to go put this back to where they're all right justified, and the way that I do that is simply get rid of the specification because right is the default value. So now I have them back to where they're all right justified. Now notice how these numbers could get big. So I have a field that's 8 big, so let's go ahead. We've got a number here that has 5 digits long. So let's go 7, 8, 9, Let's make it 9 digits long and see what happens, because that's too big for our field, right? So if we run it now, and we're right justified, so it says, okay, create a field that's 8 big and put 345 in it. Then create a bit field that's 8 big and put 782, 543, 87. And it fit because it's 8 big, but look how it mushed up against there. Let's do one more so we can get too many in that field. And what do we have? So a field that's 8 big, it puts 345 in there. Then it makes a field that is 8 big, which goes right to there, and it tries to put that whole number in, but that number spills over outside of the field because there are really 9 digits in it. So what happened to the next field? Well, the next set W starts after it gets done printing that number. The number was too big, so it filled up the field with it, and then whatever was left over spilled over. And then the next field began at the end of that number, so notice how we lost our order here. So you want to make sure you always make it big enough for your very biggest number. So let's go ahead and make it 12, and that should give us plenty of room. And there, now that even larger number fits. So these ones have all been dealing with integers. Let's go ahead, and I've got some numbers down here that I want to use that are floating point numbers. So type double is what these are defined at. So I'm going to replace these integers with some double numbers and see how those look when we print them out. And look at that. There we have those numbers all lined up and being printed. Notice some differences here. This number looks exactly the same. This looks a little different. It actually took off those last 2 digits. And this one, it dropped a couple of digits. And down, when we get down here, this one looks like it's dropped all of them. And then this one has gone to some funny number scheme. This is actually a scientific notation. What's happening here is there is a command that sets the precision, which identifies how many significant characters to display. And the default value for this is 6. So what's this showing us is 6 significant digits. So if you count these digits, 1, 2, 3, 4, 5, 6 significant digits. And so it's going to give us as close to the value of this number as it can with only 6 digits. Notice that it rounds. We have more digits than it needs, so it rounds. Here we can see that over here as well. 1, 2, 3, 4, 5, 6, and the 7 is rounded down because of the 3. Here, this one, we have 1, 2, 3, 4, 5, 6 numbers, so it drops all the digits on the right because it already has 6, and it still rounded that up to a 5. Now on this one, 494390, those are the first significant 6. Those are the 6 most significant digits. But if it just printed those, we would think it was talking about 494,390, and that really is not the number at all. So when it can't represent a number, the value of it, with only 6 digits, it will set it into scientific notation. So it gave us those 6 significant digits, 49439, and then raised to the power of 7. So there we get our significant digits. But what if we didn't want it to go to scientific notation? Well, there's a way that we can change it to always stay in fixed point notation. So the command for that is fixed. And what that says is, don't go back and forth between standard notation and scientific notation. We want you to always, always, always stay with that standard notation, which is called fixed point notation. Now when I run it, what happened? The numbers changed. Notice we got rid of this scientific notation, but what happens when you do this, it changes how set precision works. Remember we said the default value for precision is 6 digits? So what it does is once you set the fixed flag, then precision no longer means how many significant digits. Now it identifies how many digits are after the decimal place. So each one of these numbers is now written with 6 digits after the decimal place. And if they didn't have any, it just put all zeros. Right? So it just fills them up until they're all zeros. Let me show you how that would be. So here's one that, let's go ahead and not put any value on it, and let's see what we get. And there it fills them all up with 0. So it gives us 6 digits after the decimal place. Well, we can change the precision as well. So let's say we don't want we don't want 6 digits after the decimal place. Let's say that we only want 2. I can put a numeric constant there of 2 as well. I'm going to put it on the line before. And let me cap that since it's a constant. So there I set the precision to 2. And so set precision requires an argument. All right, now let's do it. All right, there we have it with 2 digits after the decimal place in every case. All right, so precision by default is 6, and it identifies how many significant digits to display unless the fixed flag is set. Once the fixed flag is set, then it tells us how many digits to put after the decimal place. So setting the fixed flag changes what set precision does. All right, now notice how we've lined those up all very nicely around the decimal place. Well, once you set it fixed and you give them all exactly the same precision and right justify them, they're lined up by the decimal place. There's one more command we want to learn about, so I'm going to change this program over to do something different. So let's go ahead, and here I've got labels, hamburger, large drink, ice cream cone, and I'm outputting these variables, which are the prices associated with those things. And now when I print it, so here we still have this problem where everything's pretty messy and not lined up. So let's go ahead and set the width. Now notice how these labels are quite a bit longer than the prices, so I'm really going to need 2 here. Constant int, so I'm going to have name width, and I'm going to make it 18 big. And then I'm going to have another one for price width. And I'm going to make it just, let's make it 6 big. All right, so now I'm going to do set widths here. But this one, oops, I forgot my insertion operator. Got to have that for each one. This one is going to be for name width. And I'm going to want that in front of every label. So I want that to be there and there. So I want that width to be there. Over here in front of hamburger price, I don't want it to be name width, I want it to be price width. And I want that to be on each one. All right, now let's run it and see what it looks like. And there's a few things we need to fix here, right? So first off, let's fix this so these ones are left. And remember how we do that? We simply do a cout left, and that will left justify. Okay, so this is left justified. Ooh, but now these are left justified as well, which is not what I want. Doesn't show us here very good about what happens, but let's say that this cone price, instead of being the same distance, let's show it to be 85. And this will really show us how it doesn't line up. So now, when these are left justified, they no longer line up with decimal values. And also notice that we're not getting that trailing zero on the 140, right? Because it doesn't add any value there, so it doesn't print any trailing zeros. Well, we want to print it so it shows that it's 40 cents. How are we going to do that? Well, to do that, what we need to do is we need to set our precision. So let's go ahead and set the precision. We want this to be 2. So I set the precision to 2, and that will clear up that one problem. Well, not quite clear up that one problem. What else do we need to change the precision? Remember what set precision does? It gives you the it sets how many significant digits. So that 285 went to 2.9, we only got 2 digits, 1.4, 85. So what it did is it set the number of significant digits, which is not what we want. We want the number of significant digits, but we want it to tell us how many are right of the decimal place. So we also have to set the fixed to change the way set precision works, because what we're looking for is 2 digits after the decimal place. So there, now we have 2 digits after the decimal place, and now they all line up. So the last thing I want to show you is notice that these fields are being filled up with spaces. So anything left over is filled up with spaces. So here's a field that is 18 big, and it puts that value hamburger in there and left justifies it, and whatever's remaining in the field has spaces in it. So you can change what's in there by using the command set fill. So if I do, and again, this requires one argument, but this argument is not a number, it's actually a character. So I'm going to fill it with the character dot. All right, and that's what this is saying, is what to fill up any remaining spaces in a field. So notice what it did. It filled it up with dots. Okay, so any remaining filled up with dots. Now I want the dot. I don't want those there. There are 2 ways that I can fix this. One is I can right justify these, so the leftover areas in the field will be on the left-hand side, or I can change it back to a space. I'm going to go ahead and right justify them, so if I get something larger than that, it will work. So notice how I set it to left, and then to get the price to be there, I need to do it to the right. So here I'm going to set it back to right, and I want all the prices to be right justified, so I'm going to put that in front of every price. Now watch what happens. As soon as I made this one right, it stayed right, so that these labels were right justified too. So what I have to do is, after this right, since I want this one to be left, I have to go back in here and put left, right? And that left will stay until it gets to the right, and then it'll go right. Then it'll come back and it would still be left. Still be right, so I need to set that to left. Now I have it. Now I have these ones left justified, these ones right justified, and I've filled it all with dots. All right, those are the commands in the iomanip file that we are using. Remember what all of them are. There's justification, either left or right. Set precision, which does 2 different things. If the fixed flag is not set, it tells you how many significant digits to print. If the fixed flag is set, then it tells you how many digits to display after the decimal place. The fixed flag forces all the numbers to be printed in the standard fixed point notation. Set fill identifies what to fill up the rest of the field with, if there's any space left over. And then set width creates one field that you can put a value in. Notice how all of these stay until you change them, except set width you have to repeat over and over again.